Hey guys, this is my RET-217 Capstone project and my exploration into crystal cell battery technology. Just want to mention this is not my invention. It's basically a variation of the work done by John Bedini and John Hutchison. And the reason why I chose this project is the thought of having a battery cell that could recharge itself seemed pretty cool, and I wanted to make some for myself. So over the course of this video, I just wanted to go through some of the experiences I had, what worked for me and what didn't work for me. So I hope you enjoy it. So one of the first things I did was take a 3 1/4 inch diameter copper tubing, and I cut them into 2.5 inches. Next, I took each tube and filed it down the best I could. It's pretty difficult because the files I bought were super tiny. And yeah, that took a little bit of time. So here's all the copper tubing all cleaned up after taking a Brillo pad to each one and buffing it with some Brasso. During my ordering process, finding a magnesium rod that would fit my needs in a short amount of time was pretty difficult. I ended up getting them from a place called firesteel.com. And here's a picture of me cutting them down to size. I cut them to 2 1/8 inch length, and they're a 1/2 inch diameter. So here's the magnesium rods all shined up. I'm using the same method, Brillo pad and Brasso. So these next few photos are going to be me drilling the rods, installing the little bolt I put in there for a terminal, and cutting off the heads. So next I want to cover the process I took of turning those copper tubing into semiconductors. Here is a mixture of borax and water. It's a high concentration of borax. I ended up melting it on the stove so it could work better. I used a butane torch to oxidize the copper pipes. The first round I let it cool for about 5 minutes and dipped it in a borax solution. And I repeated the process 2 more times, heating it and quenching it right away. And the end result was pretty awesome. I had a lot of fun doing this. The first time I quenched the copper in the borax solution, it was really dirty, but after the 3rd time I was surprised to find it super red when I took it out. And this is the oxidation that makes the copper a semiconductor. Next I want to cover how I made these little epoxy spacers to keep the magnesium off of the copper, to keep it from shorting. I took just a tiny bit of that copper pipe, turned it into kind of a mold for the epoxy, taped up the copper with just regular tape, and lined it with olive oil so it would slip out. So here's all the epoxy spacers I made. This task was really quite boring. Literally just watching glue dry. Takes probably about an hour for each spacer to harden. So this next photo is these little PVC washers I made to kind of hold the magnesium in place and to help keep all the crystal in when I pressurized it. I had to reduce the diameter of the PVC using a heat gun, and I shoved it into the copper pipe so that it would fit very snug. So here's a picture of the chemicals I used in each cell. I got the recipe from a YouTube channel called Lasersaber. He used equal parts aluminum, potassium sulfate, borax crystals, Epsom salt, and potassium chloride. The only thing different I did was add iron pyrite to the mixture for doping. Here's a photo of all the metal parts after its last cleaning and before construction of the crystal cells. Alright guys, so I got all my prep ready for my crystal cell batteries. I have this copper tubing cut to 2.5 inches, oxidized for semiconductor. My magnesium rods with my terminals all cut and polished, my resin spacers and my PVC washers. Got my iron pyrite grinded down. These are the chemicals I'm going to use. And this is going to be for my other terminal. I'm going to wrap that around the copper, and I'm going to use the epoxy to put everything together. So right now I'm just getting ready to construct these cells. Alright, so I just got done attaching my copper end caps to my copper pipes. Use the epoxy to kind of hold that down. They're all cured and ready to go. The next step would be to slide these resin pieces I made down the tubing and slide a PVC washer down, which I made from this pipe here. I had to reduce the diameter so it would fit in the copper. And I took some rubber bands that were made for braces and wrapped them around the ends of my magnesium, kind of serve as a centering kind of buffer for my magnesium. So all that goes down the copper pipe. After that, I'll take this little funnel here I made from a soda bottle. I'll put that over my copper pipe and use this PVC rod to kind of compact everything around the magnesium. And after that, I'll slide another PVC ring over the top just to cap it off and put more epoxy on the top to keep it all together. And that should be it as far as my crystal cell batteries go. So here's all the tubes with the resin and the PVC washers in. All I need to do now is drop in the magnesium rods and pack the crystals in. So this photo was taken right before I filled it with the crystal mixture and pressurized it. After I filled each cell and pressurized them, I took some 1500 psi epoxy to cap off the top. And once again, epoxy, and working with epoxy is very tedious. So much went wrong with bubbling coming up from the crystals, but I got it done. I then took a file and kind of rubbed off some of the semiconductors so that I could attach a copper wire to serve as a positive terminal for my battery. So this is one of the first cells I did with the crystal pressurized in the cell, and I'm going to test voltage. So 1.45 volts, and now I'm going to do amperage. So not bad, showing about 130 milliamps just from the get-go, but I think it'll drop So here's my completed battery cells, all 12 of them. Just got done finishing the epoxy probably about 4 hours ago, and I tested a few of these cells. I've been getting voltages between 1.3 to 1.6 volts per cell, and amps or milliamps from 35 milliamps to 210 milliamps. It usually takes a little while for it to settle, so I can get good numbers, but just to show you that it works, I'm gonna set this to DC volts. Kind of see what kind of voltages we're getting after it settling. So not bad, 1.37 volts. Now I'm gonna do current. So I got current set on 200 milliamps for that cell. And I get these spikes. Some of them go all the way up to past 200 milliamps and then they settle lower. Here it slows down. Let's see, about 52 milliamps on that cell. Quick, I just want to show you the variance in amperage I get in these cells, and it could be because of a number of different factors. Maybe the amount of pressure I put in each cell, or the amount of crystal I put in each cell, or even the length of the magnesium I put in each cell, or the oxidation. But here I'm just going to do voltage real quick. Voltage seems to be pretty stable in all of the cells. It's about 1.43 in that one. And for amperage, and this one's showing a lot higher amperage than the rest. So there you go. So I put some LEDs on this breadboard, and I'm gonna use a 2-cell circuit and a 3-cell circuit. Some of these LEDs need much higher voltage to light all of them, but a 2-cell would light all of these, just not very bright, except for the red for some reason. So here's the 2-cell circuit. And lights them up pretty bright. I'm happy with that. Here's the yellow. And here's the white. So these are just with 2 cells. And blue. And now I'm going to try the 3-cell circuit. Alright, here's positive. And negative. So this is 3 cells. a lot brighter than the others. Here is yellow. White, that's really bright. And blue, which is super bright. So that's with just 2 cells and 3 cells up there. I'm gonna try, I got a little jewel thief circuit I could try with 1 cell. I need to figure that out. And I still got some extra cells. I'm trying to get probably like a motor started, a little fan, but we'll see how it goes. All right, so I found this little helicopter. It has 2 tiny motors on it. I'm gonna try and get it to turn with 1 cell. So first I'm gonna try the small motor. It seems to work just fine. I'm going to try and turn the bigger motor off 1 cell. It's turning. Not fast. I'm going to try this 3 cell circuit on that bigger motor, see if I can get it to turn faster. Yeah, that's better. You can actually feel the wind coming off of it. So it's got some good torque on it too. Okay, good morning. I decided to leave these blue LEDs on throughout the night. Got it hooked up to 3 cells. I just wanted to see how much power it used. It's been on for probably about 8 hours. So let's check the voltage. Let me get some light on. Still shining pretty bright. I'm still showing, you can actually see it charging. Once I took it off, I was showing about 2.9 volts. Probably lost close to a volt in 8 hours. It's actually charging pretty quick. That's pretty cool. the time-lapse video of the 3 cells charging actually cut out at I think about 3.8 volts. But it's been about 45 minutes, 50 minutes, and now I think it's fully charged at 3.95 volts. And during that time I ripped open an old DVD player, got a couple of motors out of it, and I hooked up this fart machine and tried to kind of run it off 2 cells, but it works okay. So here is that motor that spins the DVDs. And it spins pretty well for 1 cell. And here is the smaller motor. This moves the DVD, I think, into place when you click the button for the CD to come out, or the DVD to come out. That's that motor there. Try and hook that one up. That one works pretty well off 1 cell. And I got this little fart machine. Yeah, doesn't work very well, but it makes some noise. And that's off 2 cells. Just for fun, I hooked up 4 different circuits, 1 to each row of these LEDs. So hooked up 2 cells in series to this motor. It's been running probably about 10 minutes now, and I'm just curious to see how long it would take for this motor to drain these 2 batteries. So the motor finally quit after about 40 minutes, and now I'm going to do some readings, voltage readings. It's running about 0.95 volts. And you can see it charging. Just 2 little cells here. Now I got 12 cells all hooked up in series, and I just kind of want to get total voltage for all of these cells. So 16.12 volts, which isn't pretty bad. Now I wanted to check the current and 12 cells in series. So 41.6 milliamps is the average. I also wanted to add a photo of the scrum board I used to help me get my tasks done and keep things in order. Of course, it wasn't this organized through the whole process, but yeah, it helped a lot. All right, so there you go, guys. That's my crystal cell battery project. Some notes I wanted to add. I did try and get a little desktop fan to work, also a little radio to work, but just couldn't, simply because I didn't have enough amps. Also, I was supposed to hook up my cells to a super capacitor bank, but they were pretty expensive, and by the time I got that all hooked up and figured out, it would probably be the end of the term, so I scrapped it. Also, that little jewel thief circuit I was supposed to make work kind of didn't, because I broke some components, but looks like I didn't need that circuit to light some LEDs anyways. So that's all I got. Hope you enjoyed everything. Thanks for watching. It was really good knowing you all and going to school with you, and just want to wish you good luck in the future.